Let's learn about dividing radicals part 2. So in part 1, we have already learned how to rationalize a denominator, but in that case, the denominator is a monomial. So in previous class, you had learned about if you have a denominator which is a radical. So let's say if it does have a coefficient. So we had learned that if you multiply with as it is, or you can just multiply with the radical part, it will rationalize the denominator, meaning that we will get rid of the radical part. So what happens here is you get 9 root 4, and you get 15 root 2. So having a radical number in the numerator is okay, but we just don't want it in the denominator. So once we have this, we can then see if we can reduce, but our main idea is at this point we have done rationalizing, but we will always reduce it further. So this both can be divided by 3, so it gives you 5 root 2, and it gives you 6 here, and that's it. You can't reduce the 2 and the 6 because this is a radical number and this is a whole number. So remember the rules of division: radicals divide radicals, whole numbers divide whole numbers. What we're going to learn today is what happens when there is a binomial in the denominator. So if you try to multiply it and apply the same idea of multiplying this binomial with exactly what it is, which is root 5 minus 3, and if we do something to the new denominator, we have to do it to the numerator as well. So once you do this, what will happen? So let's try to see if we can FOIL this out over here and see what happens when you have this. So you remember, the idea is that we should not have any rational numbers in the end. So this will give you root 25. These will give you negative root 15. This gives you negative root 15. And then this gives you plus root 9. So this gives me a 5, this gives me a 3. That's good. However, in the middle, we still end up with 2 root 15. Now, if we combine everything that we can, we weren't able to get rid of the radical number in the denominator. So my denominator still has a radical number in there. So this idea of multiplying the binomial with exactly what it is doesn't work. So we can't use that. So what do we do with it? So if you guys remember when we, a few classes ago, we learned the idea about a conjugate pair. And remember what the conjugate pairs did? It did the a square minus b square. And we talked about how that is how you end up actually getting rid of the middle term, because that's what happens when we FOIL it out. Well, I don't want you to FOIL it out. Actually, I want you to remember that this here is the difference of square scenario. So what you can do is when you're multiplying those two is to think of a square minus b square. Okay, so that means it's the first term squared minus the second term squared. So this is from 2 lessons ago when we first did multiplication of radicals. This was towards the end where they talk about conjugate pair. So if you have missed that, please go visit that idea again. So what happens here is the first term squared minus the second term squared. And whenever we do that, this is going to give me 25 minus root 9, which is 5 minus 3. And bingo, that's what we want. We want the denominator to become a rational number, a whole number with no radicals in there. The numerator, we're going to simply distribute this. So we have 2 root 5 plus 2 root 3. I haven't reduced this yet, but my main idea about rationalizing the denominator is done. Once you do this, in the end, what you want to always do is try to reduce from all your terms a common number. So I can see that every coefficient, which is a whole number, is a 2. So I'm kind of going backwards here. So you could have done it a previous step also, is I take out a 2 from the numerator, and it will divide the 2 in the denominator. Okay, it will reduce it. So my final answer comes out to be 5 root 5 plus root 3, and with nothing in the denominator or a 1. So the big idea that we're learning here is that if you have a binomial as a denominator, okay, we can rationalize it by multiplying it with its conjugate pair. Okay, so conjugate pair is same terms with the opposite sign. So if you have a negative here, you will multiply both the numerator denominator with positive, and if this was a positive, you would have multiplied both of them with negative. We don't care what is in the numerator. This is only based on what is on the in the denominator. Okay.